JARVIS from Iron Man and Cortana from Halo are both examples of highly advanced AI companions that have a track record for contributing to the protection of Earth and even the galaxy. And it got me thinking, I should make my own AI companion that can check the weather and update my calendar. So let's take a look at what I'm trying to build in this project. I want to build a system where I can submit a prompt or ask a question to an AI assistant and it performs a task or responds back to me. However, I don't want the system to be limited to just one thing. Instead, I want my AI assistant to be capable of performing a number of tasks and work out for itself, based on my question, how it should complete the task. Luckily, there are now well-established open source frameworks that enable the development of multi-agent architectures, such as LangGraph, which is the one I'll be using in this project. LangGraph allows for the development of supervisor multi-agent architectures whereby specialized agents are coordinated by a central supervisor agent. This means that a user will only interface with the supervisor agent, and based on the question or prompt, the supervisor will decide which worker agent is most suited to the task and delegate that task appropriately. Additionally, each worker agent can be assigned a set of tools to support them in completing a given task, and we'll go more into detail on agent tools later in the video. When it comes to building this project, it's split into two parts. I need to develop a backend that manages all of the agents and the tools and any API connections that we discussed earlier. And I'll be developing a web-based front end where I can send messages, see responses, and see status updates from the backend. I started by developing the backend. Firstly, I wanted to get my Python scripts running in the command line and configure and validate all of the agent operations. My original plan was to have a completely on-premise solution. This would mean all of the AI processing would be done locally on my computer, and I wouldn't have to rely on cloud services which might incur costs. However, when I first started testing local models using Llama, I ran into a couple of issues. First issue was the runtime. The computer I'm working on has limited hardware, so isn't able to run local models very quickly. What this meant was each agent operation would take a considerably long time to finish. And the second issue, I actually found when trying to mitigate the first, I started using lower parameter models, which meant they would run faster on my computer. However, these models didn't perform very well with the LangGraph framework, and often would not trigger the tools that were available to them. To mitigate these issues, I switched to a cloud-based language model. Fortunately, Google's Gemini models can be accessed via an API with a fairly generous free tier, so the current version of my AI assistant is taking advantage of Google's Gemini 2.0 Flash model. And after testing with this model, both the speed and the capability of the model was significantly better than those local tests that I'd tried previously. With the new Gemini model in place, I was able to successfully test the multi-agent architecture with two agents. The first was the Space Launch Agent, which used the Launch Library API that I used in my Launch Map project to get upcoming launches. The second agent was the Weather Agent, which used the Open Weather API to get current weather for a given location. Before moving on to the UI, I wanted to add a couple more agents and tools to enhance what my AI assistant could do. One of the agents I added was a Todoist agent. This agent had control over my to-do list. Specifically, I gave it the ability to add new tasks to the to-do list and to view what my current tasks were and report them back. The other was a calendar agent that was able to add new events to my Google Calendar and view scheduled events on my calendar. With all of my agents in place and working on the command line, I revised my Python backend and wrapped the AI interface inside a Flask web server and tested it worked using Postman. Now it's time to move on to the second phase of the project, the UI development. Before I started any development, I sketched a wireframe together using Figma, which gave me a good blueprint to go off. I wanted an area to chat with my assistant, and I also wanted an area which would provide details of which agents and tools were used to process my message. Using my wireframe as a guide, I was able to very quickly put together a user interface that allowed me to send and receive messages with my AI backend. Comfortable with this functionality, I updated both the front and back end to send a log of the agents and the tools that were used to respond to my message. By having this log visible, I can quickly and easily see from the front end how the AI has decided to handle my query. This extra information can allow me to validate that my query has been handled correctly. With the UI now meeting most of my requirements, I only had one update left to make. Currently, the response from the backend was being served as one complete payload once all operations have been completed. That meant for more complex tasks that take a longer time between agents, I don't get an update until the supervisor agent is returning the final response to me. So I further updated the backend to return the response as a stream each time there is a new update available, and the front end to handle this stream and display each individual update as they return. This ended up providing a much better user experience, clearly showing that the model is still processing the response and providing interim updates. That's as far as I'm taking this project for now. In future videos, I plan to update my assistant to receive voice prompts and respond audibly. I also want to update the agent architecture to handle more complex requests with multiple tasks in a single prompt. As usual, all of the source code for this project is available on GitHub, and you can find the link in the description below. Stay tuned and subscribe for more projects like this in the future.